Hi everyone, welcome back to Cody's Lab. So today I have a dog whistle and a sound spectrum analyzer here loaded up onto my phone. So we've got frequency along this axis, intensity on this axis. And what I want to do today is blow some different types of gas through the dog whistle and see what effect it has on the sound that it puts out. But of course, to compare, we're going to start with air. Fair warning, if you're sensitive to high-pitched noises, you might want to turn down the sound or take your headphones out, whatever you need to do. So here we go. I'm just going to blow with my breath for now. Okay, so it looked like the peak sound from that was at about 9,000, 8 to 9,000 hertz, which is well within the range of human hearing. Now that's kind of interesting because, aren't dog whistles supposed to be so high-pitched you can't hear? Well, with this particular whistle, that is not the case. This is just a cheap one that I bought from the pet store for about $7. So it's not like it's a high-end silent whistle or anything. But that really doesn't matter for what I'm trying to teach today. So first thing I want to try doing is changing this to a longer length so that those sound wiggles don't go away quite as fast. So now we can, see, now it stays there for a little while longer so we can see more of an average of what the sound is being put out. Let's actually put a piece of tape right there so I can write on my screen now. And now let's actually hook this up to a balloon to eliminate any sort of bias based on my breath. Okay, so I've got this balloon filled with air. It's just hooked up to the whistle. Let's turn this towards the speaker. Okay, let that graph settle down and then I'll just release the air. Okay, so we got our peak right there. If you've ever taken helium and inhaled it,
you'll know that it makes your voice high and squeaky. The same thing that the helium is doing to my voice is what it's doing to the whistle.
The speed of sound in helium is faster than it is through air. So inside the body of the whistle, the sound waves are bouncing back and forth in here. In the air, it happens about 9,000 times a second. In the helium, it was happening around 16,000 times a second because it takes a smaller amount of time for the sound wave to get from one end to the other, resulting in a higher pitch. The helium molecules weigh only about 4 atomic mass units, whereas the average in the air is right around 30. I won't get into it very much here, but take the root mean square of the mass and the temperature. The helium particles, for the same temperature and energy, move about 3 times faster than the air molecules. This means if you have a bunch of them and you give them a push, the helium is going to transmit that push much faster than the air. Here's a table of the actual speed of sound through different gases in meters per second. So you can see helium, it's over 1,000. Oxygen, it's about 320. Now you might ask, why did I only see a doubling in frequency rather than a tripling in frequency if the speed of sound through helium is 3 times faster? Well, my current hypothesis on that is that my source of helium is contaminated with oxygen, which makes it so that it overall is a heavier gas than I should be expecting. So now let's try it with a gas that is heavier than air.
Heavier molecules travel slower. So the speed of sound is slower, the sound
should be at a lower pitch. So now I have some xenon, a noble gas which is about 5 times heavier than air. You also notice that the balloon sinks a lot slower when it's got the high molecular weight gases. It's because the diffusion rate is slower. That really shouldn't affect anything but the sound intensity. Let's actually give that a test real quick. I'll squeeze the balloon to increase the pressure, and therefore increase the effusion rate. That's interesting. It kind of made two peaks. One was about here. Okay, I think I can see what's happening here. The whistle is actually putting out multiple frequencies, and the relative strengths of the different frequencies does seem to change depending on the pressure that is being put on, actually. So yeah, you get multiple peaks if you blow through it really hard. Since I marked the position of the first peak with the air, it makes sense that I should mark the first peak with the xenon as well. This means that the xenon did produce a frequency about half of what the air did, as you'd expect from the speed of sound. And actually there was a third peak that I only noticed with the xenon. This means that that peak would have been out beyond the audible range, which means this whistle does produce some of its sound outside the audible range. So it does work. Hope I haven't annoyed the neighbor's dogs too terribly. I haven't heard them barking, so I think we're good. And hope you guys enjoyed. I'll see you next time.